Yeah, welcome back everybody. We continue with the questions on polynomials. The last one we did was number 5. And I think we have only done the first part, Roman figure 1. Given that f of x equals 2x cubed plus px squared plus qx minus 5, find the values of the constants p and q such that the remainder is 8 when f of x is divided by x plus 1 and 35 when it's divided by x plus 2. We've done that already at that Roman figure 1. We've done that and we got the values of p and q. P equals 13 and q equals 2. Now to Roman figure 2. Find the remainder when f of x is divided by x minus 2. Now that I know p and q, I can state f of x completely. That simply means f of x, which is let me copy that, 2x. This is f of x. I can now write it in full by substituting the values of p and q. F of x, which is this, is equal to 2x cubed plus p. What's p? P is 13 plus 13x squared minus q. Q is 2. That's minus 2x minus 5. This is f of x in full. Now, what's the remainder when it's divided by x minus 2? When f of x is divided by x minus 2, the remainder is f of 2. We are using the remainder theorem. If you divide f of x by x minus 2, the remainder will be f of 2. Just say x minus 2 equals 0, and that means x equals 2. So the remainder will be f of 2. Now let me find f of 2, and that means 2 into bracket 2 cubed plus 13 times 2 squared minus 2 times 2. That space is not going to contain it. I should write it on a single line. F of 2 equals 2 times 2 cubed plus 13 times 2 squared minus 2 times 2 minus 5, and that's equal to 2 cubed is 8 times 2, that's 16. 2 squared is 4 times 4 times 13 is 52, and that's minus 4 minus 5, which is equal to 16 plus 52. Let's do that here. 16 plus 52, 16 plus 52, 16 plus 52 minus 2 minus 5. No, minus 4 minus 5. 16 plus 52 minus 4 minus 5, and that's equal to 59. So the remainder when f of x is divided by x minus 2 is 59. Now we go straight to the next, which is number 6. Let me get the question. Yeah, that's 6. Number 6. The next one is number 6. And now, okay, let me copy and paste that. Number 6. Now this is number 6. Yeah, that's number 6. When the polynomial h of x, which is equal to dx cubed plus fx squared minus 7x minus 6 divided by x minus 1, the remainder is minus 10. And when it is divided by x minus 3, the remainder is 36. Find the values of the constants d and f. Okay, let's go straight to the solution. The polynomial is h of x, and it's equal to dx cubed is equal to dx cubed plus fx squared minus 7x minus 6. Now, when it's divided by x minus 1, the remainder is minus 10. That means h of 1, when it's divided by x minus 1, the remainder is the same as h of 1. And the value of that remainder is minus 10. That simply means h of 1 equals minus 10, which simply means d times 1 cubed plus f times 1 squared minus 7 times 1 minus 6 equals minus 10. And this means d plus f minus 7 minus 6 equals minus 10, which simply means d plus f minus 7 minus 6 is minus 13. And when that goes to the right hand side, it becomes minus 10 plus 13, which is 3. So d plus f, let me write this plus well so it doesn't look like the f. D plus f equals 3. That's our first equation. Now, when the polynomial h of x is divided by x minus 3, the remainder is 36. When you divide h of x by x minus 3, the remainder is the same as h of 3. And the value of that remainder is 36. That means h of 3 equals 36, which simply means d into 3 cubed, d times 3 cubed plus f times 3 squared minus 7 times 3 minus 6 equals 36. You just put 3, substitute 3 for x in h of x. That simply means 27d plus 9f minus 21 minus 6 equals 36, which means 27d plus 9f minus 21 minus 6 is minus 27. When that goes to the right hand side, it becomes plus 27. And we're going to add, that means we have 36 plus 27 on the right hand side, which is 36 plus 27, that's 50, that's 63. Albert's correct. 36 plus 27. You can always check to be sure. 36 plus 27, that's 63, that's correct. So we can divide through by 9 to make the equation simpler. That will be 3d plus f equals 7. And this becomes our second equation. Now we solve equations 1 and 2 simultaneously. Equation 1 is d plus f equals 3. Let me write that. D plus f equals 3. And equation 2 is 3d plus f equals 7. Now I want to subtract equation 2 from 1. D minus 3d is minus 2d. F minus f is 0. And that's equal to 3 minus 7, minus 4. If I divide both sides by minus 2, I'm going to get d equals 2. That's d. Now putting d in equation 1, d plus f equals 3 means equation 1 is d plus f equals 3. That simply means 2 plus f equals 3, which means f equals 3 minus 2. And that means f equals 1. Let's see, what's the question? Are we just to find the values of the constants d and f? Yeah, we're just finding the values of the constants d and f. So d equals 2 and f equals 1. And that answers the question very, very simply. Now we go straight to the next, which is number 7. Number 7. Let me get a question. Number 7. Let's put that here. No, yeah, that's question 7. Yeah, that's number 7. I think this part, there's an R here. Yeah, that's number 7. And it says if h of x is equal to x squared plus 5x plus 6, if h of x equals x squared plus 5x plus 6, is a factor of p of x equals ax cubed plus 4x squared plus bx minus 6. Find Roman figure 1 the values of the constants a and b. Roman figure 2 the remainder when p of x is divided by x minus 2. Okay, that's a simple one too. We go to the solution. Now h of x, this is the first one. H of x, Roman figure 1 is what we're doing first. H of x equals x squared plus 5x plus 6. X squared plus 5x plus 6. And it is a factor of p of x, which is equal to ax cubed plus 4x squared plus bx minus 6. Now, if h of x is a factor of p of x, that simply means if we factorize h of x, the factors of h of x are also factors of p of x. So let me do that first. H of x, which is x squared plus 5x plus 6, is equal to, I'm factorizing h of x, is equal to x squared plus 3x plus 2x. By now, I'm sure we can factorize. And that simply means x into bracket x plus 3 plus 2 into bracket x plus 3, which is equal to x plus 2 times x plus 3. So the factors of h of x are x plus 2 and x plus 3. That simply means x plus 2 and x plus 3 are also factors of p of x. Now, if x plus 2 is a factor of p of x, that simply means p of minus 2 is 0. Because the remainder when p of x is divided by x plus 2 is going to be 0. And that simply means a times x cubed. Let me bring the p of x down. P of x, this is p of x. P of x equals ax cubed plus 4x squared plus bx minus 6. So if it's divided by x plus 2, if x plus 2 is a factor of p of x, that means p of minus 2 equals 0, which simply means a times minus 2 cubed plus 4 times minus 2 squared plus b times minus 2 minus 6 equals 0. And that means minus 8a minus 2 squared is 4 times 4 plus 16 minus 2b minus 6 equals 0, which is the same as minus 8a minus 2b. 16 minus 6 is 10. When you take that to the right hand side, it becomes minus 10. And we can divide through by 2 to get minus 4a minus b equals minus 5. No, we can divide through by minus 2, which makes the equation 4a plus b equals 5. That's equation 1. Now, x plus 3 is also a factor of h of x, which means it is also a factor of p of x. When p of x is divided by x plus 3, the remainder is p of minus 3. Since x plus 3 is a factor of it, that means the remainder will be 0. So p of minus 3 equals 0. And that simply means a times minus 3 cubed plus 4 times minus 3 squared plus b times minus 3 minus 6 equals 0. We just substituted minus 3 for x in p of x. And that simply means, that's the same as minus 27a plus 36 minus 3b minus 6 equals 0, which simply means minus 27a minus 3b. 36 minus 6 is 30. When that goes to the right hand side, it becomes minus 30. Now we can divide the whole of this by minus 3, and that gives us 9a plus b equals 10. That's equation 2. Now we want to solve the two equations simultaneously. The first one is, what's the first equation? 4a plus b equals 5. 4a plus b equals 5. And the second equation is 9a plus b equals 10. Now if we subtract 4a minus 9a is minus 5a. b minus b is 0. And that's equal to 5 minus 10. That's minus 5. If we divide both sides by minus 5, then we get a equals 1. Putting a in equation 1, that simply means 4a plus b equals 5 is the same as 4 times 1 plus b equals 5, which means 4 plus b, or let me just go straight to it, b equals 5 minus 4, and b coincidentally is also 1. B is also equal to 1. Yeah, so, and what's the question? Let's go back to the question to see what we have to do. Find the values of the constants a and b. That's the first one. And the second question, find the remainder when p of x is divided by x minus 2. So I already have the values of the constants a and b. A equals 1 and b also equals 1. Now to the second question, which is Roman figure 2. Find the remainder when p of x is divided by x minus 2. Now I can state p of x fully. P of x is now equal to, p of x is ax cubed plus 4x squared. Let me just copy it from here. This is p of x. Ax cubed plus 4x squared plus bx minus 6, and that's equal to 1x cubed, which is x cubed plus 4x squared plus b is 1, that's 1x, which is the same as x minus 6. Now what's the remainder when this p of x is divided by x minus 2? The remainder will be p of 2, which is 2 cubed plus 4 times 2 squared plus 2 minus 6, and that's equal to 2 cubed is 8, 2 squared is 4 times 4 is 16. Let me write that. 8 plus 16 plus 2 minus 6. 8 plus 16 plus 2 minus 6. And that simply means 8 plus 16 is 24 plus 2, 26 minus 6, 20. So the remainder when p of x is divided by x minus 2 is 20. That simply means remainder equals 20. Now can we go straight to the next, which is number 8. Number 8. Let's see that. This is number 8. I'm getting a question. Number 8. And that will be here. Let's put it here. Number 8. Yeah, this is number 8. Now, what does the question say? If the polynomial f of x equals ax squared plus 13x plus b, if the polynomials, there are actually two polynomials, f of x equals ax squared plus 13x plus b, and g of x equals 4x squared plus px plus q are divided by x minus 1, the remainders are 12 and 6 respectively. If they are divided by x minus 2, the remainders are 40 and 20 respectively. Find the values of the constants a, b, p, and q, and hence determine the values of x for which f of x equals g of x. Okay, how do we go about that? Now, f of x rather, f of x equals ax squared plus 13x plus b, ax squared plus 13x plus b, and g of x, okay, yeah, and g of x equals, let me write the two polynomials first, and g of x equals 4x squared plus px plus q, 4x squared plus px plus q. Now, when both of them are divided by x minus 1, the remainders are 12 and 6 respectively. When f of x is divided by x minus 1, the remainder is 12. That simply means f of 1 equals 12. When f of x is divided by x minus 1, the remainder is f of 1. And the value of that remainder is 12. So that means f of 1 equals 12. So that's what I'm doing. And which simply means a into bracket 1 squared plus 13 times 1 plus b equals 12. And that's a plus 13 plus b equals 12. Which means a plus b equals, when 13 goes to the right hand side, it becomes minus 13. It becomes minus 13. So that's 12 minus 13, which is minus 1. That's our first equation. Now, when g of x is divided by x minus 1, the remainder is 6. Yeah, when g of x is divided by x minus 1, the remainder is 6. That simply means g of 1 equals 6, which means 4 times 1 squared plus p times 1. I'm just putting 1 in g of x, plus p times 1 plus q equals 6, which is the same as 4 plus p plus q equals 6. And that means p plus q equals 6 minus 4, which is 2. You take this 4 to the right hand side and it becomes minus 4. So on the right hand side you have 6 plus 4, which is 2. And this is the second equation. Now we're solving. Okay, no, we can't solve simultaneously yet because the equations are of different terms. The first one has a and b, while the second has p and q. Now let's get further information. When they are if they are divided by x minus 2, the remainders are 40 and 20 respectively. That means when both of them are divided by x minus 2, when f of x is divided by x minus 2, the remainder is 40. And when g of x is divided by x minus 2, the remainder is 20. So f of 2 equals 40, which simply means, what's f of x? A times 2 squared. That simply means a times 2 squared plus 13 times 2. I'm just putting 2 in f of x, plus 13 times 2 plus b equals 40. That's a remainder when f of x is divided by x minus 2. This simply means 4a plus 26 plus b equals 40. And that's 4a plus b equals 40. When this one goes to the right hand side, it becomes minus 26. 40 minus 26, that's 14. And that's another equation. Let's call it 3. Now, when g of x is divided by x minus 2, the remainder is g of 2, which is 20. Yes, when f of x is divided by x minus 2, the remainder is 40. When g of x is divided by x minus 2, the remainder is 20. And that simply means, what's g of x? G of x is 4x squared plus px plus q. So that simply means g of 2 is 4 times 2 squared plus p times 2 plus p times 2 plus q equals 20, which means 16 plus 2p plus q equals 20. And that simply means 2p plus q equals, When 16 goes to the right hand side, it becomes minus 16. And we have 20 minus 16, which is 4. That's another equation 4. Now we can solve similar equations simultaneously. I want to solve equations 1 and 3 simultaneously. Yeah. So let's see. Let's do that. Equation 1 is a plus b equals minus 1. Let me just take that there. A plus b equals minus 1. This is equation 1. And equation 3 is 4a plus b equals 14. This is equation 3. 4a plus b equals 14. So I'm solving that simultaneously with equation 1. Now what do? We can subtract simply to eliminate a. A minus 4a is minus 3a. B minus b is 0. Equals minus 1 minus 14 is minus 15. And when you divide both sides by minus 3, we get a, which is equal to 5. Now putting a in equation 1, a plus b equals minus 1. That simply means 5 plus b equals minus 1, which means b equals minus 1 minus 5, and that's minus 6. Now we solve equations. What are the equations in terms of p and q? Equations 2 and 4 simultaneously. This is equation 2. That's equation 2. What's equation 4? This is equation 4. Equation 4 is 2p plus q equals 4 rather. This is equation 4. 2p plus q equals 4. Now we're solving these two equations simultaneously. I can do that also by subtraction. P minus 2p is minus p. Q minus q is 0 equals 2 minus 4. That's minus 2. And that simply means p equals 2. If I put p in equation 2, I'm going to get 2 plus q equals 2. And that simply means q equals 2 minus 2, which is 0. Therefore, a equals, what's a? A equals 5. B equals minus 6. P equals 2. And Q equals 0. So those are the values of a constant A, B, P, and Q. Now let's go to the second question. What's the second part of the question? It says, and hence determine the values of x for which f of x equals g of x. For what values of x is f of x equal to g of x? Before we do that, we need to write both of them in full. F of x, not p of x. F of x equals, what f of x? F of x is ax squared plus 13x plus b. Ax squared plus 13x plus b. Ax squared, yeah, this is f of x. And that's the same as, now that we know a is 5. That's 5x squared plus 13x plus b, which is minus 6. That means minus 6. Now g of x, let's state g of x fully too. G of x equals 4x squared plus px plus q. G of x is 4x squared plus px plus q, and that simply means 4x squared plus p, which is 2, that's plus 2x plus q. Q is 0, so that's just 0. And now for what values of x is f of x equal to g of x? If f of x equals g of x, that simply means 5x squared. That simply means 5x squared plus 13x minus 6 equals 4x squared plus 2x. Now, I can bring the whole of the left hand side to the right hand side, and I'm going to get 5x squared plus 13x minus 6 minus 4x squared minus 2x equals 0, which means 5x squared, no, that's 5x squared minus 4x squared, that's x squared. 13x minus 2x, that's 11x, and then minus 6, okay, that's all, minus 6 equals 0. Now we can factorize this. This is going to be x squared plus what is it going to be? 11x. I hope this subtraction is correct. Let me see. 13x, yes. What's x? I'm checking my substitution. Okay, 13x plus b. Okay, let's see. 13 minus 2, that's 11. How do we get that? Okay, I don't think this is factorizable, so we can use the formula method. X equals minus b, which is minus 11 plus or minus root b squared, which is 11 squared minus 4ac, that's minus 4 times 1 times minus 6 all over 2a, which means 2 times 1. By the way, a is 1, b is 11, and c is minus 6. So if you use the formula method, this is what you're going to get, and that's equal to minus 11 plus or minus root 11 squared is 121. Let's get on our calculator. 121 plus minus 4 times 1 is minus 4 times minus 6 is plus 24. So we have 121 plus 24, and that's 145. So that's the square root of 145 all over 2. And that simply means minus 11 plus or minus 145. What's the biggest perfect square that can divide 145? Let's see. Let me divide by 16, no? Let's divide it by 145 divided by 25 will not be. Let's see, 49, no? Okay, I think I should just write. I can just leave it this way. It's not compulsory to state it fully. Let me write it as 11. Okay, let's see, 145 divided, or I can just write it as a decimal to save the stress of. That's 12.042 plus 12.04. That's 12.0415, 0416. Let me write it that way for more accuracy. All over 2, which simply means minus 11 plus 12.0416 over 2, or x equals minus 11 minus 12.0416 over 2. So that simply means x equals, let's do the first one, minus 11 plus 12.0416 divided by 2. That's 0.5208, or x equals minus 11 minus 12.0416. That's equal to 23.0416 divided by 2. And that is minus 11.5208. So those are the values of x for which f of x equals g of x. Now can we go to the next very quickly? That should be number 9. Number 9. I want us to stop at 10. Number 9. Let's bring the question. Number 9. This is question number 9. Question 9. Now that's number 9. And then we go straight to it. Given that the polynomial f of x equals 3x cubed plus ax squared plus bx plus 2 as x minus 1 as a factor and leaves a remainder of 4 when divided by x minus 2, find the values of the constants a and b and hence determine the other factors of f of x. Okay, f of x as, this is the solution, p of x, f of x rather, f of x is equal to 3x cubed plus ax squared, 3x cubed plus ax squared plus bx plus 2. This f of x has x minus 1 as a factor. If x minus 1 is a factor of f of x, that simply means f of 1 is equal to 0. In other words, the remainder when f of x is divided by x minus 1 is 0. So that means 3 times 1 cubed plus a times 1 squared plus b times 1 plus 2 equals 0, which simply means 3 plus a plus b plus 2 equals 0, and that's simply a plus b equals 3 plus 2 is 5, and when you take that to the right hand side you have minus 5. A plus b equals minus 5. That's equation 1. Now what else can we deduce from information given? Okay, it leaves a remainder and leaves a remainder of 4 when divided by x minus 2. If it is divided by x minus 2, the remainder will be f of 2, and the value of that remainder is 4. When f of x is divided by x minus 2, the remainder will be f of 2, and we are told that that remainder is equal to 4. So that simply means f of 2 is 4, which simply means 3 times 2 cubed. I'm just putting 2, substituting 2 for x in f of x. 3 times 2 cubed plus a times 2 squared plus b times 2 plus 2 equals 0. And that means 2 cubed is 8 times 3, 24. 24 plus 2 squared is 4 times a, 4a plus 2b plus 2 equals 0. And this simply means 4a plus 2b, 24 plus 2 is 26. When you take that to the right hand side, you get minus 26. So 4a plus 2b equals minus 26. We can divide through by 2 to get 2a plus b equals minus 13. And that's another equation. Now we want to solve the two equations simultaneously. A plus b equals minus 5 and 2a plus b equals minus 13. I can simply subtract equation 2 from 1. A minus 2a is minus a, b minus b is 0. Minus a equals minus 5 minus minus 13. That simply means minus 5 plus 13, which is 8. Minus 5 plus 13 is 8. Minus a equals 8. That simply means a equals minus 8. Now we put a in equation 1 to get b. Equation 1 is a plus b equals 5. A plus b equals minus 5 rather. This is equation 1. A plus b equals minus 5, which means minus 8 plus b equals minus 5, and b is therefore minus 5. When minus 8 goes to the right hand side, it becomes plus 8. So b will be minus 5 plus 8, which is 3. Now we got, so that means a equals minus 8 and b equals 3. Now let's go back to the question and see what we're to do next. Find the values of a and of the constants a and b, and hence determine the other factors of f of x. Okay, now that simply means we can write f of x in full just to be able to factorize it. F of x, which is 3x cubed plus ax squared. This is f of x. F of x equals 3x cubed plus ax squared plus bx plus 2. And that's the same as 3x cubed. A is minus 8. That's minus 8x squared plus bx, which is plus 3x plus 2. Now we want to find the other factors of f of x. Can there be other factors? Or okay, yeah. We only have one factor. We have only one factor. We have only one factor, so we want to find the other factors. You can find the other factors by simply dividing f of x by one of the factors that we already know. They said f of x equals 3x cubed plus ax squared plus bx plus 2 as x minus 1 as a factor. So we are just dividing f of x by x minus 1 to get the other factors. So let's do that. 3x cubed minus 8x squared plus 3x plus 2 divided by x minus 1. 3x cubed divided by x, that's 3x squared. Now we multiply the whole of this by 3x squared, and that gives us 3x cubed minus 3x squared. What happens when we subtract? 3x cubed minus 3x cubed is 0. Minus 8x squared minus 3x squared is the same as minus 8x squared plus 3x squared, and that's minus 5x squared. We bring down the next term, which is 3x. Now minus 5x squared divided by x, that's minus 5x. And now we multiply again the whole of this by minus 5x. That gives us minus 5x squared plus 5x. Now we subtract again. Minus 5x squared minus 5x squared is 0. 3x minus 5x is minus 2x. We bring down the next term, which is 2. And we go again. Minus 2x divided by x, that's minus 2. Now we multiply the whole of this by minus 2 to get minus 2x. Minus 1 times minus 2 is plus 2. And now when you subtract, the remainder will be 0. So that simply means f of x, the factors of f of x are x minus 1 and 3x squared minus 5x minus 2. 3x squared minus 5x minus 2. We want all of the factors, so we must split this quadratic factor into 2 because it should have 3 factors. Since it's a cubic equation, since it's a polynomial of degree 3. So what is 3x squared minus 5x minus 2? That's equal to 3x squared. How do we do that? Multiply minus 2 by 3x squared. That gives us minus 6x squared. We now think of 2 factors such that when we multiply, we get minus 6x squared, and when we add, we get minus 5x. And those factors are simply minus 2x and minus 3x. So instead of writing minus 5x, that's what I'm going to write. 3x minus 2x minus 3x minus 2. So that was just for, to remind us of factorization. And that simply means x into bracket 3x minus 2 minus 1 into bracket. I think this needs to move to the left, minus 1 into bracket 3x. What did I do here? 3x plus 2, where they should be the same. 3x squared minus 2x minus 3x minus 2. What's common to 3x squared and minus 2x? That's x. X into bracket 3x minus 2 minus 1 into bracket. Is that going to be minus 1? I think this arrangement is a bit tricky. Oh, minus 5. What an error. if we factorize 3x squared minus 5x minus 2, I don't think we were right. Minus 2 times 3x squared is minus 6x squared. So what do we multiply to get minus 6x squared and add to get minus 5? That's going to be 1x minus 6x. That's it. 1x minus 6x is minus 5x, and 1x times minus 6x is minus 6x squared. So my factors should actually be, so that simply means it should be 3x squared. The factors are 1x minus 6x minus 2. The factors are 1x and minus 6x. So it shouldn't be what I wrote earlier. It shouldn't be minus 3x minus 2x. Sorry about that. That was a mistake. That's why it's good to always check again, because at most of the time, mistakes are inevitable. So that simply means x into bracket 3x plus 1 minus 2 into bracket minus 2 into bracket 3x plus 1, and that's the same as x minus 2 times 3x plus 1. Now therefore the complete factorization of f of x is x minus 1 times x minus 2 times 3x plus 1. So this factorizes f of x completely. That means we have got all of the factors of f of x. Now to the next, which is number 10. Number 10. That looks like a short question. Number 10. This shouldn't be difficult. Yeah, number 10. If g of x equals f of x plus 1 and f of x equals x squared plus 3x plus 2, find the remainder when g of x is divided by, this is actually divided by x minus 1. Now g of x, what's the solution going to look like? Let's say that g of x is the same as f of x plus 1, and f of x is x squared plus 3x plus 2, x squared plus 3x plus 2. Now we need to be able to find g of x. That's f of x, so that simply means g of x, which is f of x plus 1, is going to be equal to x plus 1 squared plus 3 times x plus 1. Just put x plus 1 whenever you see x in f of x. And that simply means x squared, if you open the bracket, plus 2x plus 1 plus 3x plus 3 plus 2, which means x squared, 2x plus 3x is 5x, and 1 plus 2 plus 3, that's 4, that's 6. So that simply means g of x equals x squared plus 5x plus 6. Now find the remainder when g of x is divided by x minus 1. When g of x is divided by x minus 1, the remainder is g of 1. No, g of 1, which is 1 squared plus 5 times 1 plus 6, and that's 12. The concept of the remainder theorem is very, very useful when you solve questions on polynomials. And g of 1 is 12. That means the remainder when g of x is divided by x minus 1 is 12. And that's it, very, very simply. All right, thank you very much. That was kind of long, but I think and hope you got everything. That's where I'm going to stop, and we'll take more questions later. Thank you very much, and I'll see you in the next.